respected session chair, the august gathering and the organizers of ICS CC 2017, greetings to you all. Myself Suman from NIT Agartala Computer Science and Engineering Department. I am going to present the paper titled Augmented Sign Language Modeling with Interaction Design on Smartphone. Basically, this is an assistive learning and communication tool for inclusive classroom. The inspiration of the work started when we first analyzed that the inclusive classroom largely addresses the people which is very common in several that is physical challenges, that is hearing impaired and speech impairment. Now, in my presentation I have started with one inscription where it is known as the school of Aristotle. And from the beginning of human civilization, we already know that cave paintings were first some known expression by which people could express their ideas to other person. Now, this has been grown large and we have different form of language as present time, which is largely used in terms of knowledge transfer in classroom. Now, in present scenario, there are different medium of communication like visual, verbal, non-verbal, so many things. In this work, we try to emphasize on the work which is called augmented reality, and it is particularly emphasized for a teaching learning tool in classroom. Now, the central concern of this work is to associate technology in a very cost-effective manner and a rapid manner. Now, while coming to the matter of augmented reality, it is something different or in between, you can say, reality and virtual reality. In augmented reality, we remain present in the actual system and we try to find out some alternative way of communication or executing some work. As mobile is becoming very popular, we try to explore how mobile can be a very effective tool for teaching, learning or sign language representation for a teaching as well as for communication purpose. This work is a very preliminary work when we tried to model the three-dimensional instruction system by gesture. And by this we want to mean that when sign language is taught to a person like physically that is otherwise abled, hearing impaired another person, the instructor and the students, there is a communication by only visual communication. So, in that case a rigorous training required. Unfortunately, till of our analysis and knowledge, the sign language representation in India is also having a different challenge. In different part of the country, different signs are utilized for a single purpose. So, in one way we can say there is a lack of till the standard sign language which can be accepted by all people from different geographical region. But that is a different issue. In our work, we try to find out how it can be better modeled when a teaching or communication term comes. So, here just skipping this mobile augmented reality, the details of this, we are directly coming to the purpose of this augmented reality which can be utilized better for as educational tool or mobile augmented reality as an educational tool. When we initially started, we found several tools for educational supplement using mobile are there. Some of the names are Quiver, Element, Blipper and so many things. So, these are different educational aspects and different educational tools can be used. Now, here I just used one slide just to analyze whether it is an effective work, whether it is a meaningful work or is there any kind of significance in that work at all. From human computer interaction point of view, the first thing came up that those people who are not able to speak, those who are not able to listen, where the visual information is the only means of communication, then the inclusive classroom becomes difficult for the teacher as well as for the students. Actually, the inclusive classroom is a model where the regular people and the special need people, they all together take the class from the same teacher. Now, if it is the case, then the teacher must be getting some equipment by which the communication can be translated or it can be properly communicated to the person who need it in alternative way. So, this is a categorically focused work where the purpose is to equip the teacher as well as make the student interactive and interested to the component what is going to be delivered to the student. Now, this is a temporal scale work. That means when the class is going on, there cannot be any kind of lag or there cannot be any kind of gap. So, as I mentioned that this work is a very preliminary work in way of thing. So, this is our objective and analysis of the initial work. Now, as a prerequisite of the whole system, when we started, we found that sign language representation is in 2-dimensional. That means, unless an instructor is before the students, the things are on a flat 2-dimensional system. So, the movement of the finger or movement of the system or proper representation is not available in an easy manner. So, our first task was to model the hand movement, particularly which is very common in sign language representation. For this, we have used Blender 3D modeling, but Blender 3D modeling had given us some kind of say static models. So, by Unity game engine, these were dynamic, but the problem was that how those movements can be recorded and these movements can be interpreted. So, the second challenge was to design a sequential system by which the whole modeling, that means the 3-dimensional model, can be a live one. So, for this we tried to explore the flex sensors, and we have just remodified one glove where fingers were equipped with the flex sensors, and those gloves movement, that means when the fingers are moved, these potential differences of this electricity could be transduced by the Arduino and can be transferred to the computer, and the Unity game engine transferred the same system to the Blender models, and they can make a movement. The primary objective is, if a student want to learn the movement, the student can wear the glove and the movement can be done, and according to the movement, the teacher can find out whether the exact movements are happening or not. On the contrary, the teacher can record the movement where the same patterns can be recorded in a database, and that can be reverse find out that whether the patterns are matching or not. So, this is a trivial pattern matching system which I have not discussed in this purview of the paper. In this paper only it has been focused how the model can be transferred or model can be translated from a flat model to a live interactive model. So, application development, when we thought it came up as a marker based application development, where a trigger or a 2-dimensional image marker can be triggered for finding out the relevant movement of the hand or representation of the sign language in 3D models. So, a range of 3D models created which are equivalent to some of the alphabets. For this particular purpose, we have chosen Hindi language, and the Hindi language alphabets is an equivalent sign language representation. So, here the prototype design for Hindi language depending on the Hindi alphabet as a marker. So, what exactly happens when a mobile is placed before the 2-dimensional printed of any letter of the Hindi, the equivalent sign language sign representation of that letter is shown on the screen in an augmented, that means you can say augmented reality manner. That means you can see the real image or a real letter, along with that the 3-dimensional modeling of the representation. So, this is a one just a prototype only. When we started this experimentation, whether it is effective or not, we found very interesting result. Here in this paper, no numerical result been presented, only anecdotal and quasi experimental systems been presented. And here you can find out some description given that we worked with some group of children, and all of them were hearing impaired, and they have some kind of physical and neuromotor disability also. These children had a different reaction towards the whole system, as those children were initially facing problem, because you can understand when the disability or some kind of limitation in limbs come, it is not so easy to grasp the system as very easily you can understand from someone's voice. So, definitely it is not interesting also, and these systems are getting challenges from multi-dimension. So, our work was to make the system interactive, interesting, as well as less effort in learning. Though there are a lot of works to be done to find out, numerically identify how much that is effective, how much it is essential from human computer interaction point of view, how much it is that means effective in terms of learning or retaining. But at present what we can just present here, the whole system can be extended for a betterment and easy learning, and anecdotal representation initially reported that not everything is very exciting or not everything in a positive manner. There are also some difficulties, because when people are finding these augmented reality matter, it is not used to, these people are not used to. So, when it is shown to them, initially some of the students have reported it is very difficult, because their sense of accepting the system was different. Then after one trial or when the teacher shown, then it became very interesting to the student, because initially they were not understanding what is the purpose. So the purpose of the system when once taught by the teacher, because the system was also new to the teacher. So here in this slide I just presented some of the description that how the teachers also reacted and how the students also reacted. So this cannot be treated as a numerical conclusion of experimental result. It is just an anecdotal report about the acceptability of the system. And once the paper was this particular domain paper had written, now we are planning about a numerical analysis about the whole experiment and how can be treatment group, how can be one that means trial group can be found out, which can utilize the system and can tell about numerical changes about their usage. In this diagram I just want to show that how the glove, flex sensor, Arduino and the relation of smartphone. That means when we are connecting the glove is not directly connectable at this moment with the mobile phone, but the system can be connected to the PC. So when the glove is there and the movement can be recorded in the PC in terms of a training set, and when those training sets are triggered by the mobile camera, then they can be found out that the markers that say O, A, E, these markers can be connected to the system. Conclusion, so if you design one model of hand, all the letters, we have concerned here Hindi, that can be any kind of local languages or any other words can be modeled. That means one model of hand we only designed. The movement and other subsequent representation of different letters were composed by this glove. So you can understand that only it took one effort to create one hand model, rest of the things are variable. So here the procedure also that means the procedure of particularly testing how we experimented or anecdotal report connected, that has been represented here. So in again in conclusive system, if we want to summarize the effect and the purpose of this paper and how it can be called a technical paper, so that can be layered only from human computer interaction point of view. That means one real system, in between there is an augmented reality and there is a teaching learning effect or outcome. So this mobile is featured here as an augmented reality intermediate thing, and our computer system is used here along with the glove as creating the content for those augmented reality. So I hope the system could give a very effective result. Here I am showing some of the screenshot that how the 3D model and the glove can be connected, and the effectiveness of the whole system is the design of the hardware is very low cost. It is within even 1200 rupees, or we can scale it down less. And the 3D designs, once it is done, it can be utilized for a better training purpose, that how sign language can be trained to the student, and the teacher's effort that making a proper sign language can be very meaningful. So the next thing, that when we represented it into a that is hearing impaired school of our locality, a group of students, they were initially they were very small kids of class 2 and class 5 and so on. So they all levels people were very much excited. The excitement in that level we want to add up as learning attention and learning interest. We are really excited that this low cost system it is implemented, that will be very good implication for those hearing impaired people, at least up to the learning level from this ready system. So in conclusion, just I want to add here a few very precise points. The objective of the proposed work is to facilitate the learning of the letters like Hindi vernacular system or any local language system till there is no standard or declared standard system available for sign representation in words or phrase system. The system can also be extended to particularly implement the augmented reality in real time classroom interaction for a special able student. By this just it is by now it is already clear that if a person is teaching physics and the person is a normal speaking person, then his content, that means voice, can be translated to some of the text, and text can be again translated to the sign representation. So there can be a large extension of the whole work. So only we want to find out that the exact usability of the whole system, once it is numerically proved, then its extension or the use can be large because it is not only for teaching purpose, even daily life communication can be also very effective for the hearing impaired people. Due to some of the limitation, I could not attend the conference, and that is my bad luck. But I am by my heart I just want to wish everyone a great success of the whole conference. I'm sure you might have a lot of queries and lot of suggestions for me. At this moment, I am not readily able to answer you, but I will be taking up all your suggestions and questions. If it is forwarded to me, I will try to improvise or I will try to answer. But that was really a good experience for me to share my presentation to you through this video system. Hope this science and technology has extended us, that staying here at Tripura, I can present my paper, though it is in offline, to you all before the conference team. Once again, all my best wishes for the conference organizers, and really it's a great platform, and I hope in next conference physically maybe I will be presenting there. Thank you all, and thank you to the organizers for giving this opportunity to present the paper. Once again, thank you.